All right. So, here we go. Any specific questions for me about anything before I jump into stuff? Yeah, Lindsay? 14 and 15. Okay, those are great questions. Glad you asked those first. Okay, so these are the free response questions. Okay, the ones that I kind of printed out the full size for you. I will tell you right now, you will have questions just like 14 and 15 on tomorrow's test. Okay, will they be the same? No, but same kinds of stuff here. Okay, so let's see what we got to do. So we have a postman's route. A postman walks his mail delivery route each day at a constant rate. The equation below, d of h equals -2 absolute value of h minus 4 plus 8, models the postman's route where d of h represents the distance in miles he is from the post office over h hours on any given day. Okay? So we're supposed to first graph the situation and we want to label our axes. Okay? So if you look here, right, what quadrant is graphed? Can you tell? This is just the first quadrant right here, okay? We have the positive part of the x-axis down here, with the positive part of the y-axis here, which should make sense because in this context, right, we're talking about h, a number of hours, right, which should never be a negative number, and then also a distance, which a negative distance doesn't really make sense either, right? So that's why we're only in the first quadrant here. So hopefully you didn't draw like a y-axis right to the center and an x-axis right to the center, right? This is our x-axis right here. This is our y-axis right here, okay? So in this case, right, h is like our x, right? So that means our label down here is going to be hours for h. Okay, and our y-axis label here, well, that's the d of h, and d is representing what in this case? Distance. Yeah. So this is distance, and I'm going to put in parentheses in miles. Okay, this is the distance from the post office. Okay, just like that. Now, if you look here, we have to graph this thing, right? Okay. The kind of transformations that I see here, we need to go right 4 and up 8. Okay, so let's see if I can fit that in my graph here if I just count by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then I have to go up 8. So let's see here. 1, 2, 3, 4, 5, 6, 7, and 8. That is going to fit. Okay, so I only need to count by 1s on the x-axis and 1s on the y-axis. Okay, and so I'm going to move right 4 and up 8. Here's the origin right here. Right, there's 0, 0. So right 4, up 8. That is the vertex of my absolute value. Okay, and then to get more points, remember that's our slope right here in front. Right, so it's -2 over 1. So from this point, what does that -2 over 1 tell me to do? Down 2, and then right 1. Right. Down 2, right 1, down 2, right 1, down 2, right 1. I'm going to stop here. I am not going to continue graphing for obvious reasons. We run out of graph, but also because it would not make sense for me to keep graphing because I'm going to have a negative distance if I keep going down, and that doesn't make sense in the context here. Okay, in this story, right, we'd stop at 0. Okay. Besides going down to right 1, what other way should I go?
Down to left.
Down to left 1 for the symmetry of our absolute value function. That's right. So down to left 1 there. And again, we'll connect those dots. And again, don't go beyond that 0, 0 because it would not make sense in context. Okay? So there's the graph. All right? And it asks us in letter B to find the domain in the context of the situation. Okay? So what is our domain here in the story, in the graph, or the story of the graph?
0, 8.
Yeah, 0 to 8, exactly right, okay? So, and we're going to include the 0 and 8 there. Okay, starts at 0 and goes to 8 hours, right? What is the meaning of the domain? What do these numbers represent? Not distance, it's domain, right? So these are the xi's. What do the xi's represent? The hours, right? It's the hours the postman works each day. Okay, 0 to 8 hours, right? Typical 8-hour day. All right. Letter C, what is the maximum of the function? Just the highest point. So what's the maximum here?
It was 8.
Yeah, so 8, we can say y equals 8, or if you give me the coordinate for 8, that's okay too. Okay, what does that maximum represent in this case? Tyler?
Just the 2 travels.
Yeah, it's the farthest away that he gets before he starts to return to work, right? He's going further away from work. The maximum away he gets is 8 miles, and then he starts to return to his workplace, right? So the farthest he gets is 8 miles from work. Okay. When is the postman exactly 6 miles from the post office? So when means we are looking for a time, right? When means a time, right? So at what time is the postman exactly 6 miles from the post office? Look at your graph. At what time is he exactly 6 miles away from the post office? 3 and 5, right, okay, if you look there, here's 6 miles away, there's a point, but there's a point as well. So it's at 3 hours and at 5 hours, okay? So at 3 hours and 5 hours, okay? Or you can say at h equals 3 and h equals 5, that's fine too. When is the postman more than 4 miles away from the post office? So now we'll go to 4 here on the y-axis, okay? And here is where he is exactly 4 away. We want to know when he is more than 4 hours away. So how will we describe that? More than 4 miles away. So more than 4 miles would be this part of the graph right here, right? So between what 2 times is he more than 4 hours away? Yeah, 2 and 5. Yep. So between 2 and 5 hours. Okay, between hour 2 and hour 5, if you like. Question?
For B, F, H3, H5, H2, H6, is that good?
Like h equals 3, h equals 5, or just h3?
H3.
Put an equals there, if you would, please. Just because h3, to me, indicates you're multiplying, right? When you have an h and a 3 next to each other, that means multiplication. So put an equals there just so I know what you're talking about. Okay. All right, letter F. What is the postman's average rate of change? When we see average rate of change, that means we are finding the slope. Okay? You don't need to know the slope. I'll give you a formula sheet tomorrow that has the slope formula on it. It is, y2 minus y1 over x2 minus x1. Okay? Just like that. So, in this case, 0 and 4, are those x's or y's? They're in hours. Are hours the x variable or the y variable in this case? They're the x, right? They're on the bottom. So 4 and 0 are going to go on the bottom. I need to find their matching y values. Well, at 0, the y value is also 0, so that's easy enough. Okay, so 0. But at 4, the y value is 8. So I'll put an 8 there for that matching y value. So the points are 4, 8. I'll write that up here maybe. 4, 8, and then 0, 0. And we just subtract. So 8 minus 0 is 8, 4 minus 0 is 4. And I'm going to simplify. You don't have to simplify, but I think it's good, right? So I'm going to get 2 over 1. Interpret the rate of change in the context. So that means we're just going to label our variables here. 8 and 0, what are their labels? They're the y coordinates, right? What's the label for the y coordinates in this problem? It is miles, right? So this would be miles. And then what's the label for the x coordinates? Hour. So just read label. 2 miles every 1 hour. Okay, so the postman walks an average rate of change of 2 miles per hour. Okay, from 0 to 4 hours. Okay, and there's that. All right, once you get that down, go ahead and turn the page. We'll do this one. Do this one really quick here. Let's see. What I'll try to do, since I don't know if we're going to be able to finish going through this whole thing, I will try and during my planning, I will try to record for the rest of the questions there, okay, and then get those posted as well. Okay, I'll try and like put that all together in one single video. See how that works. Okay, hopefully that should work. All right. In the meantime, though, let's flip over to the back. We're going to graph this thing. Okay, so I see some transformations here. -4 means we're going to go right 4. That +2 means you go up 2, and that 3 is our slope, right? So right 4, up 2, and then the slope. I'll put that in like quotes, though. I mean, it's kind of the slope. But anyway. So right 4, be careful, we're counting by 2s here. So right 4, up 2, it's going to be this point right here. Okay, right 4, up 2. And then to count 3, you want to be careful here, okay? Count up half blocks, right? 1, 2, 3, and then over a half block. Because we're counting by, these blocks are each 2. I need to count by 1. So 1, 2, 3, and then right 1, and there's a nice point right there. Okay, and again, we can do the opposite. Up 3, left 1, up 3, left 1. Okay, and there's our graph. Okay. Domain. What is the domain of this graph going to be? What's the farthest left we're going to go? What's the farthest right we're going to go? Yeah, it's just -infinity to infinity here, okay? Is the range also -infinity to infinity? What's the bottommost point? 2. And we get there. And the highest point is? Infinity, okay? Given g of x equals 5, for what values of x does f of x equal g of x? Show your work on the graph above or solve algebraically below. G of x equals 5. Remember, that's the same thing as saying y equals 5. The line, y equals 5, is a horizontal line that goes through at 5. Here's 5 right there, right? So we're just going to draw this horizontal line. This is g of x equals 5. Okay, g of x equals 5 is just this horizontal line. Okay, for what values of x does f of x, our absolute value, equal g of x? The line here. Well, you can see it right there in the graph. Just look. Here's f of x. Here's g of x. Where are they the same? At what x values? What's this x value right here? 3, yeah, and 5, right? Yep, exactly right. 3, halfway between the 2 and 4 here, that's the 3, and halfway between 4 and 6 is a 5. So it's just x equals 3 and x equals 5. If you're like, Mr. Witt, I don't know if I'm going to be able to, graph that, okay. Another way to do this is to just take your function here, f of x, that's given to us, set it equal to g of x, which we know is just 5, and then solve there. Okay, so you can get the 2 from the graph, or you can also just set the 2 functions equal to each other. F of x, which is the 3 times absolute value x minus 4 plus 2, and set equal to g of x, which is just 5. And then you just solve that equation. You guys know how to solve absolute value equations, right? Okay, letter D. And by the way, any quick questions? I just want to make sure I don't miss anybody in the dust here. We're all okay so far? Okay. Paige, but you're left in the dust?
Yeah.
Okay. You just stop? All right. Well, it's going to be recorded up there, so you can look at the video if you need to and go back and stuff. But anyway, all right, our function here, f, right, which we graphed right here. Okay. Now we're going to take f, and what is this x minus 2 going to do? How's that shifted? Right, how much?
2.
And this minus 5 is going to do what?
Shift it down 5.
Down 5. So this graph of f that we have right here, we're going to move this graph right 2 and down 5. Now, if you want to redraw f here, that might not be a bad idea, just to kind of help us out. So I'll maybe redraw f real quick. Okay. Okay, so this is f. I'm going to use h here, so I'm going to have to shift it right 2. So from this point, I'll go right 2, and then I'm going to go down 5. So there's 1, 2, 3, 4, 5, and I'll put my new vertex right there. And then every other point, I'll just shift right 2 and down 5. So here I'll count over. 1, 2, and down 1, 2, 3, 4, 5, and there's a point. And then I'll have this point right here. Same thing, right 2, down 5. And I can move this as well. Right 2, down 1, 2, 3, 4, 5. And right 2, down 1, 2, 3, 4, 5. When they use that same, oh, that's unfortunate that I did that. So anyway, it kind of overlaps the other absolute value function there, so it's kind of hard. But anyway, and there's h of x. Okay. On what interval does h of x have a positive rate of change? That means it's, in other words, when is it increasing? So now we have h of x graphed. Okay, we're increasing from the x value of 6 to infinity. Okay, just 6 value, right, up to infinity there, or to infinity to the right. And then on what interval is h of x negative? It's between these 2 points, which is between 5 and 7. Okay, when the function is below the x-axis there. Okay. All right. So I'll stop there. All right, that's posted for you, so you can at least, check that out if you need to. I'll also record during my planning, hopefully, the rest of this.